Hey everyone, I hope you're doing well today. In this video, let's go over some fractions. Hey everyone, I hope you're doing well today. In this video, let's do a little bit of review for fractions. I'll go over some basics with impropers and propers, as well as mixed numbers, simplifying fractions using the GCF, adding, subtracting using the LCD, as well as multiplying and dividing, talking about some fraction models, and maybe some applications as well. So let's get right into it. All right, so for this question 1, we need to take mixed numbers and improper fractions and convert them back and forth. So just a little bit of basics here, but we just want to make sure we feel comfortable. So we have this mixed number of 5 2/3. And to convert that to an improper fraction, you just multiply 5 times 3 and then add that 2 that's in the numerator. So it'll be 5 times 3 plus 2. I'm going to write it out so it's super clear. And the denominator always stays the same, so that's going to be a 3. So 5 times 3 is going to be 15, so it's going to be 15 plus 2. That's going to be over 3. And 15 plus 2 is 17, so we have our final solution of 17 over 3. That's just the improper version of 5 2/3. And it doesn't like me right now, but that's okay. There it is. It doesn't really matter. I'm just kind of strange like that sometimes. All right, so this next one is going to be an improper fraction, so it's going to be 35/4. So while you can do this mentally, I like to also just make sure I'm showing exactly how the thought process is going to be. So we should be using standard algorithm and just say how many times does 4 go into 35. It goes in 8 times, that's going to be 32. Subtract here, that's going to be a remainder of 3. So 4 goes into 35 8 times with 3 left over, and the denominator stays the same. Okay, so that would be that solution for the second one, right? So we're just going from a mixed number, an improper fraction, to a mixed number. All right, for number 3, let's see, we have 3 5/8, so it's 3 5/8, that's a mixed number. Let's go back to improper, so we'll multiply, then we'll add. That's kind of that shortcut here, so it's going to be 3 times 8 plus the 5, and the denominator is still talking about eighths here, so 3 times 8 is going to be 24, so 24 plus 5 all over 8, and so that's going to equal 29 eighths. Okay, so that's the improper version, but again, same thing, just in a different form, and so it's important to be able to go back and forth between the two when we're dealing with fractions. Okay, number 4, let's see, we have 64/5, 64 over 5. Let's see, we can do 64 divided by 5. That means the same thing. So 5 goes into 6 one time. 1 times 5 is 5. The remainder is 1. Bring down the 4. 5 into 14 2 times. 2 times 5 is 10. We have a remainder of 4. So this goes in 12 times. 5 goes into 64 12 times with 4 left over, or 4/5. All right, there would be the mixed number version of this fraction. Okay, and there's like kind of like the little work I had on the side there. For number 5, let's see, I think I need a little bit more space. I just don't want to cramp it up too much. So we have 8 7/9. And so let's see, we have to say 8 times 9, that's how many of those parts we'll have, plus 7 more of those parts. So just to write this out clearly, it's going to be 8 times 9 plus the 7, and that's going to be how many ninths we have. So 8 times 9, that is 72. 72 plus 7, that's how many ninths we have, and 72 plus 7 is 79. So 79 ninths is the same thing as 8 7/9. That's good enough. Okay, moving on to number 6. Let's go ahead and try one more of these, just converting back and forth. So we have 53 over 12, and we want to say, well, how many wholes is that? Well, we need 12 twelfths to make a whole, so it takes 53 and divide that by 12. 12 times 4 is 48. And again, if you're not sure, you can use a calculator to divide or see how many times. Remainder of 5. And so this goes in 4 times with 5 left over, so that would be 5/12. All right, so that would be the mixed number version for number 6. All right, let's see what else we got here. We're going to simplify these fractions using the GCF. We have to use prime factorizations or the ladder method. All right, no worries. So oopsies. Number 7 here. Again, everyone's going to have their own preferences for how they like simplifying. For this, I'm going to use the ladder method. I'm going to say 80 and 96, and I'm going to see how many times a number that is a common factor. Again, if you pick a bigger number, that's great. If you don't, that's also okay. You can take your time. I'm going to start with 2 here because I think most people would maybe choose 2. And it's an even number, so that's nice to do. Again, I know there's bigger numbers, but I'm just going to try and do it this way. For 40 and 48, maybe we can do 2 again. Again, there's no shame in using a bunch of 2s. Perfectly fine. I don't know. I'll use a 2 again. That's going to be a 10 and a 12. And at this point, we could have used 8, but that's all right. And put a 2, and we should have 5, 6 at the very end. So on the side here, all these 2's together, if we multiply them, 2 times 2 is 4, times 2 is 8, times 2 is 16. So from that, we know that the GCF here is equal to 16. And from what we see on the bottom, this would be the most simplified fraction. Right here, it would be 5/6. Okay, so long story short, we should be able to tell from this that 80 over 96, that original fraction we had, if we divide that by our GCF of 16 on top and bottom, then the most simplified version of this fraction would be 5/6. All right, so I guess technically what we're really looking for the whole answer is having the GCF in there as well as the simplified part. So having that 16 in there is important. Okay, that's number 7. Again, if you wanted to use prime factorizations, you could do it as well, but I think that takes a little bit longer, but it's definitely a method that works. Okay, for this number 8, we have the fraction 28 over 56. Okay, so I'm going to use the ladder method again, and looking for a common factor. For this one, maybe I'll go a little bigger to start. I could start with 2, but maybe go with 7, right? 7 times 4 is 28, 7 times 8 is 56, and then I think using just like a bigger number here, I could use 2 and 2, but let's just use 4 right away, and we get 1/2, okay? These numbers on the side are going to tell us what I think I used a different color. These numbers on the side here are going to tell us our GCF, so 7 times 4, GCF would be 28. And then the simplified version of the fraction here would just be 1/2 here, right? So we know that our original fraction was 28 over 56. We know our GCF was 28. That's the biggest thing they had in common. And when we divide these, we get 1/2. So that would be the simplified version of the original fraction using the GCF. Okay, that's 8. Let's check out 9. 9, it looks like we have an improper fraction. No worries, works the same way. So we have 72 and 48. And so let's see what we have in common. I think our 8 times tables, 8 times 9 is 72, and 8 times 6 would be 48. And then looking at 9 and 6, they both have a 3 in common, so that's going to be 3 and that's going to be 2. And so if we take a look, whoopsies, if we take a look here, multiplying 8 and 3, we know our GCF is going to equal 24. So our original fraction of 72 over 48, if we divide the top and bottom, the numerator and denominator, by their GCF of 24, we should get the most simplified version, which is going to be 3 over 2. And you could say that's 1/2 if you turn it into a mixed number. So that would be the most complete way of maybe expressing your knowledge of how to rewrite this. Okay? So that's number 9. Sorry if you hear some random sounds in the background. So it's going to be 3 over 2 or 1/2. That's number 9. Moving on to number 10. Okay. Number 10, a lot of people look at right away and they have some trouble maybe trying to simplify this one. In this case, I don't know, maybe I won't use the ladder method just because it seems to people don't see it as clearly. Looking at 38, we know it's even, so we could divide it by 2. It happens to be 2 times 19. 57 can't divide by 2 because it's an odd number, but 5 plus 7 is 12, and 12 is a multiple of 3, so we can divide it by 3. And so 3 times 19 is actually 57. So again, this is the prime factorization method. You can cross off their GCF, and that's going to be 19. So if we divide by 19, or their GCF here, we should be left with the most simplified fraction, and that would be this 2 and 3. Right? So most simplified fraction here would be 2/3. The GCF was 19. That's what we used to get there. Okay? Again, if you divide by the GCF, you've simplified the entire fraction as much as you possibly can. All right, on to some adding and subtracting, stuff like that. So here's where we do need common denominators. So let's try to apply what we know a little bit and see if we can add these two together. So we need to find out when these two numbers meet, this 6 and this 4, the very first time they meet. So let's see, 6 and 4. Again, you could do it mentally, but I'm just going to write it out to help people who might need to see that. And so if we go ahead and see when they meet for the first time, that's just going to be 2 times 3 is 6 times 2 is 12. And so we can say, let's multiply 6 times 2 to get 12. Whatever you do on the bottom, you got to do on top. 4 times 3, and then 1 times 3. Okay, so for these new fractions, 5 times 2 is going to be 10. 6 times 2 is 12. 1 times 3 is 3. 4 times 3 is 12. So 10 plus 3 is going to be 13 over 12. And we can say that's going to be 1 and 1/12. That would be the mixed number version. 13/12 is equivalent though. All right, so there you have 11. Here's number 12. We have 7/12, and we're going to take away 4/15. All right, so we'd like to find out where these two numbers here meet for the very first time, and we can do that by using the ladder method. These numbers are a little bigger than the last ones. So 3 is a common factor, so we have 4 here and then 5. So the first time they meet we can find by just multiplying these. So 4 times 5 is 20. 20 times 3 is going to be 60. If you want to use these diagonals help. So 12 times 5 is going to be that 60. Do the same thing on top. And then 15 times the 4 will get you the 60 on bottom. So this new fraction, 7 times 5 is 35. 12 times 5 is 60. And then 4 times 4 is 16. And then 15 times 5 is 60. So here we have 35 minus 16, and that will be 19. So our final fraction here will be 19 over 60. Okay. Again, we do need to get common denominators first, and we should always be using the least common denominator when dealing with adding and subtracting fractions. Okay. First, for 11 and 12, we did have to simplify the fractions first, but you're going to notice something a little bit more interesting about 13 and 14 that you want to pay attention to save yourself some trouble. Okay, so looking at number 13 here, I don't really want to find out when 45 and 20 meet for the first time. Those are a lot bigger numbers. So if we just focus on each individual fraction, like maybe just looking at this 15 over 20, right, we can notice that we can maybe divide both top and bottom by 5 just to simplify them, right? And so if we simplify them, this new fraction would be 3 over 4, right? That's much smaller numbers to deal with. And then we could take a look at this 27 over 45, and we could divide both those numbers by 9, and that will help us get much smaller numbers as well. So 27 divided by 9 is 3, and 45 divided by 9 is 5. So I think these numbers here would be much easier to deal with and add these two fractions. So finding out when 4 and 5 meet for the first time, it's going to be 20 because they're relatively prime, or their GCF is 1. But I'm just going to go ahead and write it anyway just to be thorough and write out every single step for you guys. 1 times 4 is 4, 4 times 5 is 20, 5 times 4 is 20, and 4 times 5 is 20. And so 4 times 5, 3 times 5, 5 times 4, and 3 times 4. All right, so what we have here, 3 times 5 is 15, 5 times 4 is 20, 3 times 4 is going to be 12, and 5 times 4 is going to be 20. So adding these two together, 15 plus 12 is going to be 27 over 20, and we can write that as 1 and 7/20. All right, so there we go. That would be the most simplified version of this addition problem, and we didn't have to find out when 20 and the 45 met, because we could just simplify and find out when 5 and 4 meet, which is going to be a lot easier. Okay, number 14. Let's try another one where we subtract. So 56 over 42, we're going to take away 56 over 70. Okay, so again, I don't really want to find out when 42 and 70 meet for the first time. That sounds kind of painful. So let's just take a look at this one fraction over to the left. 56 and 42. Again, you can play around on a calculator and see what you can divide them both by, or use your divisibility rules. I do think we could maybe start with something like 14. I think 14, as far as I know, I think a 14 is a factor of both of these. So 56 divided by 14 is going to be 4. I think that makes sense. And 42 divided by 14 is going to be 3. Again, the way I knew that is I knew I could divide both 56 and 42 by 7, and then I got even numbers, so I knew I could divide them both by 2. So 7 times 2 is 14. If that's a little confusing, don't worry about it. All right, it's not that important. 56 over 70, I think you can divide them both by 7, right? And then you would get 8 over 10, which you can divide by 2. So you can divide these by 14 as well. I think that's also their GCF. So divide by 14, divided by 14. And so you would get minus 4 over 5. Okay, so it's 4 over 3 minus 4 over 5. Okay, so instead of finding when 42 and 70 meet, we're going to find when 3 and 5 meet for the first time. Okay, and that's a lot easier to do, I think. So 3 and 5, they meet at 15 because their GCF is 1. So we can just go ahead and multiply these out. 1, 3, and 5. 3 times 5 is 15. 15 times 1 is still 15. So we can multiply by 5 here, multiply by 5, multiply by 3, and by 3. 4 times 5 is going to be 20, so it's going to be 20 over 15 minus 12 over 15. And so 20 minus 12 is going to be 8. So our final solution here will be 8/15. Cool. All right, so adding and subtracting is always a little bit more annoying, so hopefully only 4 of them wasn't too bad. Again, you do need to get common denominators each time. If you can simplify the fractions first, I really highly recommend doing so to save yourself some trouble in the long run. Okay. Let's move on to multiplying, and we should be simplifying fully before we actually multiply. Okay, so if you're not sure what I mean by that, hopefully going through and explaining some of these will make it more clear. So we have 5 over 6 times 4 over 7. And so when we are multiplying, again, we can use prime factorizations, but again, that takes a little bit of time. So remember that we just multiply across. And the key thing we're trying to remember here is we can cross cancel, which means that if you see a common factor between anything on top and bottom, like these both have 2, if you divide them by 2, you get 2, and divide by 2, you get 3. And then if you can't find anything else, then you could just multiply, and then you don't have to simplify later. So 5 times 2 is 10, 3 times 7 is going to be 21, and that can't be simplified because we took care of everything before we multiplied, right? So that's 15. It's as easy as that. For 16, what do we have? We have 16 over 20 multiplied by 30. Okay, so how can we deal with this one? So 16 over 20, we'll keep that the same. 30 as a fraction is 30 over 1. Okay, we can write the 1 because we're not writing prime factorization. It's not a big deal. I think we can divide this by 10 and divide this by 10. So we just have 3 and 2. And then 16 and 2 are both even, so divided by 2, that becomes 1. And divide 16 by 2, we get 8. Okay, and so on top here, maybe it'll be helpful if I circle what I'm multiplying together here. So above here, I multiplied 5 times 2 to get 10, and I did 3 times 7 to get 21. Here, I have an 8 left and a 3 left, so 8 times 3 is going to be 24. And on bottom, what do we have? We have 1 times 1, and so that's going to equal 1. And it's a whole number for the answer here, so that's 24. All right, so I'll try to keep that pretty consistent so you can see. I know sometimes it gets a little messy with everything going on. 17, I'll skip an extra space so it's not too cramped. We have 14 over 21 multiplied by 28 over 2. So let's go ahead and write this as 14 times the 28 over 21 times 2. And let's see what we can cross cancel. Well, this one has a 7 and this one has a 7. So divide by 7, you get 2. And divide 21 by 7, you get 3. And let's see, 2 and 2 are the same number. So those can divide by 2 to get 1 and 1. And I think that's it, right? So we just have a 1 and a 28 and a 3 and a 1. So I think that's right. So 1 times 28 is 28, and then 3 times 1 is 3. I'm not going to show the long division for this, but if you want to, you can divide 28 by 3. I know 9 times 3 is 27, so we have 1 left over. And so this would be the mixed number version of this answer. Okay. All right, so that's number 17. And let's go ahead and write number 18. I think I have enough room down here to fit it. So we have 15 over 18. And let's multiply that by 24 over 45. And let's see here. It's going to be 15 times 24 on top, and then 18 times 45 on bottom. Okay, so what can we cross out here? I think I can divide both of these by 6. So 24 divided by 6 would be 4, and 18 divided by 6 would equal 3. And over here, I can divide 15 and 45, divide them both by 15. So that would be 1, and that would be 3. Okay. If you didn't see that right away, that's okay. You can divide them both by 5, then you can divide them both by 3. But I can see you can divide them both by 15, so I'm just doing that in one go here. 1 times 4 on top, and then 3 times 3 on bottom. So 1 times 4 is going to be 4, and 3 times 3 will equal 9. And there we have the most simplified version of 15 over 18 times 24 over 45. Okay. If you didn't cross cancel, you would just get really, really big numbers, and then you'd have to simplify those really big numbers, and it would just end up being 4/9 anyway. All right, so that's 18. Let's see, I guess we can go on to a new page here. Let me just double check a couple of these, make sure they seem right. I don't want to go through the whole thing and realize I made a bunch of mistakes. 2 over 3. I believe these are good so far. Again, if I make a mistake, I apologize. We all make them. And we'll try to fix them a little bit later. I'll follow up with that. So let's go to 19. We have 18 over 20. We're going to multiply this by 30 over 27. So go ahead and write them with one fraction, just so it's all together. And so if we cross cancel some things here, we can divide these both by 10, just like we did earlier. And then 18 and 27, we can divide them both by 9, and we get 2, and we get 3. This one's actually pretty interesting. You'll see why here. This 2 and this 2 are going to cross cancel to make 1s, or simplify to get 1s. And then this 3 and 3 can simplify down to get 1s. So what we have left here is we have 1 times 1, and we have 1 times 1. So this numerator and denominator are both 1 and 1, and this whole value is just 1. So technically those numbers, those fractions were reciprocals of each other. So one's 9 over 10 and one's 10 over 9, technically, if you simplify them first. Okay, so that's 18, or sorry, that's 19. Here's 20, which is going to be 27 over 36, and we're going to multiply that by 28 over 15. So we have 27 by 28, and then we have 36 by 15. All right, looking for stuff to cross out. So this can divide by 9, and this can divide by 9. That would be 3. That would be 4. This can divide by 4. This can divide by 4. We would get 7 and 1. And I think 3 and 15 can both divide by 3. That would be 1, and that would be 5. So we have 1 times 7 on top, and we have 1 times 5 on bottom. So 1 times 7 is going to be 7, and 1 times 5 is going to be 5. And as a mixed number, this goes in one time with 2 left over. So we have 1 and 2/5. Cool. That's number 20. Moving on to question 21. We have some mixed numbers to deal with here. So let me just make a little bit more room to accommodate those. So 4 and 1/6 multiplied by 3 and 3/5. Okay, so no mixed numbers. 4 times 6 is 24, plus 1 is going to be 25. Let me move this so it's consistent with the others. Just easier to keep it organized. So again, 4 and 1/6 is going to be 25 over 6. And then 3 times 5 is 15, plus 3 is going to be 18. So it's going to be 18 over 5. Okay, so make sure we always turn it into improper fractions first before we do anything else. Looking here, I think 5 and 25, you can divide both by 5, and you get 5 and 1. And then looking at 6 and 18, you can divide them both by 6 to get 1 and 3. So I think that's it. 5 times 3 on top, 1 times 1 on bottom. So 5 times 3 is going to be 15, 1 times 1 is going to be 1, and so we have 15 for our final product here. Okay, that's 21. 22, let's see what we got here. 22, we have, I can move this down a little bit. We have 6 and 1/2. and we're multiplying that by 5 and 4/13. All right, let's see how we can rewrite these. So 6 times 2 is 12, plus 1 is 13. So we have 13 over 2. And then 5 times 13 is going to be 65. 65 plus 4 is going to be 69. So that is going to be 69 over 13. Okay. Okay, I see a little bit of cross-canceling we can do. This 13 and 13 can cross-cancel to make 1 and 1, and I think that's it, not too much more. So 1 times this 69 here, and then 2 times this 1. Those are going to be what we're left with, so we'll have 69 over 2. Doing some division, 2 will fit into 69 34 times. 34 and 1/2 times. Again, you can use a calculator to check that if you'd like to, or do the long division, but it goes on 34 times with 1 left over, or 1/2. All right, and there you have up to question 22, all the multiplication problems. So moving on to the division ones here. I'll zoom in so I can see what's going on. All right, so 23, this is where the division problems start. This is where we're going to have to turn them into multiplication problems. So we have 2 divided by 1/10, and what are we going to do here? So let's rewrite this so that we have a top and a bottom for both. So 2 over 1 divided by 1 over 10, and this is where we will keep, change, and flip, or Kentucky chicken fry it, as we like to say in class. So we have 2 over 1, we're going to keep that, change the division to multiplication, and change 1 over 10 to 10 over 1. At this point, you can just multiply the tops, because I don't think we can simplify, and multiply the bottoms. So 20 over 1 is just going to be 20. All right, so that's 23. Checking out 24. 24, we have the fraction 1/5 divided by 4. So I like to rewrite them so they just have a top and a bottom. So 1 over 5 divided by 4, which is technically 4 over 1. We're going to keep this, change this, and flip this. And so that's going to be 1/5 times, and then flipping 4 over 1, we get 1 over 4. On tops, 1 times 1 is going to be 1, and on bottom, 5 times 4 is 20. So this one is actually similar to the last answer, but it's upside down. It's the reciprocal of it. All right, so it's 1/20. Let's try 25. For 25, what do we have? We have 9 over 20 divided by 3 over 5. This one I like a little more because we don't have to rewrite anything. We can just keep, change, flip. We're going to Kentucky chicken fry it. So Kentucky means we keep it. Chicken means we multiply, or we change it. And we fry it, or we flip it upside down. So it's going to be 5 over 3. So instead of me writing this as one fraction, I'm just going to go right into crossing things out. So 3 and 9 both have 3, so divide by 3, get 1 and 3. And then looking over at the 5 and 20, dividing them both by 5, we get 4 and 1. So multiplying what we have left here, it's 3 times 1, 4 times 1. Since we already crossed, canceled, and simplified along the way, we don't have to simplify after we multiply. 3/4 is our quotient here. All right, so that's 25. Let's check out 26. 26. For this one, we have 14 over 19, and we're dividing this by 21 over 19. And so we can go straight into keep, change, flip, Kentucky chicken fry. And so that'll be 14 over 19 times 19 over 21. These 19s are going to cross cancel, and that'll be a 1 and a 1. And then this 14 and 21 can both divide by 7 to get 2 and 3. 2 times 1 on top, 1 times 3 on bottom. So on top, 2 times 1, that's going to equal 2. And on bottom, 1 times 3 is going to equal 3. All right, so after all that, the quotient here is 2/3. That's 26. For 27, wait, I think that's it for now, right? 26, oh yeah, 27's over here. I thought we were done with division. It seemed a little too quick. So for 27, let's see, we have 42 over 25 divided by 7. So rewriting this with a top and a bottom, we have 42 over 25 divided by 7, which is 7 over 1. And now that we have a top and a bottom for both, I'm going to Kentucky chicken fry it. So what I'm going to do is I'm going to keep, I'm going to change, and then I'm going to flip. Okay. For 42 and 7, I divide them both by 7 to get 1, and then I get 6 here, and then 6 times 1 on top, and then 25 times 1 on bottom. So on top we'll have 6, and on bottom we'll have 25. That would be the quotient. Okay, that's 27. Let's check out 28 here. 28, we have 7/8 divided by 1/40. And I think since we have a top and a bottom, we can go straight into keep, change, flip. So we have 7 over 8, keep, change, and then flip. It becomes 40 over 1. We can cross cancel the 8 and 40, divide them both by 8 to get 1 and 5. And then 7 times 5 on top, and then 1 times 1 on bottom. 7 times 5 will be 35. 1 times 1 is 1. And so 35 would be this final solution. Whoops, that is a circle. Alright, cool. That's 28. Moving on to 29. For 29, we have a mixed number, 4 and 3/5, and we're going to divide that by 4 and 1/3. So this answer should be more than 1 just because we have 4 and 1/3 is smaller than 4 and 3/5, so it's going to fit in more than one time. So 4 times 5 is going to be 20 plus the 3. That's going to be 23 over 5. I don't know why I wrote this long line here, but that's going to be 23 over 5 divided by, and then 4 times 3 is 12 plus 1 is going to be 13. So it's going to be divided by 13 over 3. Okay? And so now that we have a top and a bottom, we can keep this, change this, and flip this. And so 23 over 5 will keep, we'll change division to multiplication, and then we'll have, instead of 13 over 3, we'll have 3 over 13. Looking around to cross cancel, I don't think we can cross cancel. Everything seems to be prime. And so 23 times 3, that'll be 69, and then 5 times 13, that'll be 65. This goes in one time with 4 left over, so it's going to be 1 and 4/65. That would be the final solution here. Okay, that's 29, and let's see. I think that's right. Let me just check real quick. That's 20. 20 plus 3 is 23 over 5. 12, 13 over 3. 3 over 13. 69 over 65. And yeah, I think that makes sense. All right, just double checking real quick. Hopefully everything is good. For 30, we have 4 and 7/8, and then we're going to divide that by 1 and 7/8. And let's see. We need to turn these into some improper fractions, so I'm just going to set this up over here. 4 times 8 is going to be 32. 32 plus 7 is going to be 39, so we have 39 over 8. And then 1 times 8 is 8 plus 7 is going to be 15, so that'll be 15 over 8. Now that we have a top and a bottom, we can keep, change, and flip. And what that's going to turn into is going to keep this thing like that. We're going to change to multiplication, and we're going to flip just so we have 8 over 15 now. And we can do some cross canceling here. I love when the numbers match. 8 and 8 just become 1, so we divide them both by 8. And then 39 and 15, you can divide them both by 3. And 39 divided by 3 is 13, and then 15 divided by 3 is 5. And so 13 times 1, and then 1 times 5. 13 times 1 is going to be 13, and then 1 times 5 is 5. And as a mixed number, 5 goes into 13 2 times, and with 3 left over, so it's going to be 2 and 3/5. That would be the mixed number version of this one. So we have 39 over 8 divided by 15 over 8. Keep, change, flip, cross cancel some work here, some numbers, and then we have 2 and 3/5. And there you have all division problems here. Moving on, to question 31, let's see if we can draw some models. So for this one, for question 31, they're saying to show how maybe 3/4 multiplied by 1/2, how that's equal to 3/8. So one way you can kind of do this is if you want to draw the rectangles out, we can do that. Maybe I'll draw them so it's going 1, 2, 3, 4. Okay, so this would be a half, and this would be a half, and we would call this a fourth, a fourth, a fourth, and a fourth. Again, this is one way of drawing the models. And so if we have 3 of these fourths, what we could do first is we can shade in 3 of these fourths. So there's 1/4, there's 2/4, and here's the 3/4. So that's 3/4 of the whole thing, right? And then we can go ahead and say, okay, going across, we have to have half. So here's half of the whole thing. So the question is, well, how do we get 3/8? How do we know that 3/4 times 1/2 is 3/8? Well, if you take a look here, there are 3 of these boxes that got shaded twice. So that's going to be 3 out of the 8 total boxes that we have. So 3 out of 8 of those size squares or boxes. Okay, so that's how to show it. That's 31. 32, how do we go ahead and do that one? Let me go up here. 32. Will that give me enough space for everything? Maybe. I'm just going to hope it does. So this one is going to be, how do you take 4½ and multiply that by 1/3 and then get 1 1/2? Let's see how that works. Well, let's try to show visually what 4½ looks like. So you have to draw some sort of area model here. So maybe we show that that is going to be one block or one hole, and we say that this is going to be another hole. We say that this is another hole, so that's 3 so far, and then here's 4, and then we have a half. Okay, so the question is okay, we have 4½ of these bars here, and the question is, okay, we have to have 1/3 of it, so we have to somehow break it into 3 pieces. So right now we can't really break them up the way they are, so let's maybe split them all into the same size pieces here. So we still have we still have all the pieces we need. So is this not working anymore? Oh no, I think my pen might have died. Let me see if I can charge this a little bit. No, it didn't die. I just can't write? Oh. Maybe it's my battery? I don't know. Alright, 1, 2, that's good now. 3, 4, 5, 6, 7, 8, 9. Okay, so wait, there's 9 of these pieces, right? And we need 1/3 of them. So 1/3 of them, well, 9 divided by 3 is 3. So let's try to show what that looks like visually. So that's going to be 1, 2, and 3. That's going to be 1/3 of them, right? And here's another 1/3 of them, 1, 2, and 3. And how do we show like the third of them? That's 1, 2, and 3. So again, we did have 4½ total things here, and the question says, how do we take 1/3 of them? And so 1/3 of them, hopefully you can see here, now that we've done this, is that ends up being that we have 1½ of these bars, right? So when we have this one hole and then this half here, that's where this 1½ comes into play. All right, so there's an area model to kind of show you, and there's no one particular way to draw the area model, but that's one way you could do it. Okay. That was 32. Let's try 33 here. 33, that's going to be 3 divided by 1/2, and that's equal to 6. Okay, so how can we draw this one out? Well, maybe I'll draw 3 holes. So there's one whole piece, and there's a second whole piece, and here's a third whole piece. So one hole, one hole, one hole, that's 3 entire things. Now the question is, how many half-size pieces can you draw? So here's a half, here's a half, here's a half. So how many times did half fit into 3? Well, it fits in 1, 2, 3, 4, 5, and 6. Okay, so if these all represented 3 holes, I could say these represent 3 whole pieces of something, right? And the question is, how many half-size pieces can fit inside of there? So this right here represents 1/2. So just drawing something like this and labeling it and showing that you understand that half fits into 3 holes 6 times lets us know that we kind of understand visually what's going on. Okay, obviously the algorithm checks out if you were to keep, change, flip, but this is visually what's happening in real life. Okay, 34, let's take 7/8 and let's divide this by 1/8, and how does that possibly equal 7? Okay, well, let's go ahead and take one long bar here. So let's go 1, 2, that'll be 1/8, that'll be 2/8, that'll be 3/8, that'll be 4/8, 5/8, 6/8, and then running out of space here. So 1, 2, 3, 4, 5, 6. We'll do 7/8. And I guess this is the 8/8 that's missing, right? The question is talking about 7/8, so we don't need the whole thing here. So this right here is going to be 7/8, this whole thing. That was way lopsided. Not that it really matters that much, but I can do a little better, maybe. That's 7/8. So the question is how many times does 1/8 fit inside here? So this is 1/8, right? So how many of these are they going to fit inside it? Well, there's 1 there, there's another one here, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. So 1/8 fits into 7/8 7 times. Okay, so being able to kind of visually show this and explain this using a couple sentences. Obviously I'm doing it verbally or orally right now, but if you can write a couple sentences to back up your model, that can be helpful in explaining how you understand why 1/8 fits into 7/8 7 whole times. Okay, for number 35 we have a word problem here, or application problem. So for 35, Bruno wants to bake some chocolate chip cookies. Each batch of cookies has 12 cookies and he wants to make 3.5 batches. Okay, so he's going to make 12 cookies in a batch. He wants to make that many batches. Each batch needs 3/4 cups of brown sugar. So how many cups of brown sugar will he need? Okay, so the 12 cookies part doesn't really make sense, or not that doesn't make sense, it's just not necessary information, but we do need that to know that he needs to make this many batches and he needs 3/4 of a cup each time. So instead of adding 3/4 plus 3/4 plus 3/4 plus half of 3/4, we could just multiply here. Okay, so again, when we need repetition of something, we can just multiply. So 3 times 2 is 6 plus 1 is 7. So what we have here is going to be 7/2 times 3/4. I don't think we can cross cancel at all, so 7 times 3 is 21, and then 2 times 4 is 8. And so 8 goes into 21 2 times. 2 times 8 is 16 with 5 left over. So the question is, how much brown sugar would he need? Well, he would be able to make, or he would need, so we can say here that Bruno needs 2 5/8 cups of brown sugar. Okay, and if he's making 3.5 batches, that would be 12 cookies, 12 cookies, 12 cookies plus 6 more cookies, and so that'd be 36 plus 6, and he could make 42 cookies. But to make those 42 cookies, he would need 3.5 times the amount of sugar, or sorry, brown sugar he needs for one batch. So he would need 2 5/8 cups of sugar, brown sugar, to make that happen. All right, so that's 35. Let's check out 36 here. For 36, we have a swimming pool. We know the area of it, so let's go ahead and kind of box this whole thing. So the area is equal to 84 3/4 square meters, and the length is going to be 10.5 meters, and they're asking for the width. That's going to be over here. So just keep in mind that when we talk about area, right, area is equal to length times width, but in this case we know what the area is, so I'll put it over here. The area is going to be 84 3/4, and that's going to be the length, or 10.5 times something, right? And so to rearrange this a little bit, we can say that the width is going to equal 84 3/4 divided by this 10 1/2. I hope that makes sense, right? Because if length times width is equal to area, then area divided by length would equal the width. So here's the area, just because I know it's a little confusing, there's so many things going on here. Here's where I rearranged everything. Okay, so the length is over here. That's the length, that's the length, that's the length, and the width is what we're looking for. So we don't know W, and so what we do know is the area. Area divided by length will get us width. So let's see if we can go ahead and solve this now. So 84 3/4 divided by 10 1/2. Let's see, 84, we need to turn this into an improper fraction. So I think what we can do here is we can do 84 times 4. So 84 times 4, I believe that's 336, and then plus 3 is going to be 339. So 339 over 4, and we're going to divide that by, and let's turn this 10 1/2 into an improper. So 10 times 2 is 20, plus 1 is 21. So that'll be 21 over 2. Okay, at this point we can Kentucky this, we'll chicken this, we'll fry this. And so that will be 339 over 4 times 2 over 21. I think we can cross cancel this 2 and 4, make it a 1 and a 2. But 339, is that divisible by 3? I think so. So we can divide this by 3. And if we do that, that'll be 113. Divide this by 3, that'll be 7. 7's prime, so I don't know if 113 and 7 have anything. I don't think so. So 113 times 1 and 2 times 7. And so 113 times 1 is still 113, and 2 times 7 is 14. So how many times does 14 go into 113? I think it goes in 8 times. What's 8 times 14? 112, right? I think 112. So I think it's off by 1. I think you can check me on that, but I think 8 times 4, 80 plus 32, 112 plus 1. Yeah. So I think the width here, the width is 8 and 1/14 meters. Just like that. All right. And there you have up to number 36 right now. Okay.